Good day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's exercise, do not forget to share, like, subscribe, and click on notification button concerning my video. Today, we are taking a topic on one of the applications of a vector. As a reminder, a vector is any physical quantity that has both magnitude. Magnitude means size and direction. I will assume that we have introductory background on vector. So today, the application of vector we are going to take is on two methods of finding the area of a triangle given the vertices of the triangle. Thank you. Consider this particular triangle and we are given vertex s1, y1, the coordinate of the vertices. We are given the second vertex. Let's say the coordinates x2, y2, and the third vertex coordinates s3, y3. So we are asked to find the area of the particular triangle. Area is just the surface of a plane shape or the surface of a curved shape. Now, how do we find the area of a triangle when we are given the vertices of this triangle? The first method is this. The area of the triangle is half the determinant of difference in the x and the difference in the y coordinates. I will tell us what I mean by this and this. Now, considering this particular scenario that we have here, I want to consider this place and this place for my change in x here, and I will consider this place and this place for my change in x here. I will also consider this place and this place for my change in y. I will consider between this place and this place for my change in y here. Now, let's start. For this particular triangle, the area is given as 1 over 2. The change in x there will be x2 take away x1 for this place. X2 minus x1. And then for this place too, the change in x will be x3 minus x2. x3 take away s3 take away x2. The same thing with the y. The change in y, as if I'm moving like this and I'm moving like this. So the change in y between these two places will be this y2 here, take away y1, and here, this y3 here, take away y2. Now, let's use this formula derivation to find the area of this triangle. The question says use two vector methods to find the area of the triangle below. Now, like I said, how do we find the area of this triangle? Now, I will label this place as my s1, y1, and this place as my x2, y2, and this place as my x3, y3. So, the area of that triangle will now be the determinant, the half of the determinant, sorry, the half of the determinant of the difference in the x coordinate here. So the x coordinates are here, I have here is minus 3, take away minus 1. Minus 3, take away minus 1. And the change in x between this place and this place will be 5, take away minus 3. 5 minus 3. Now, for the change in y, as I'm moving this way, this will be 4, take away minus 2. 4, take away minus 2. Between here and here, the y will be 5, take away 4. 5, take away 4. So I'm having a is equal to half of the determinant. Minus 3 minus 1 will give us minus 4. 5 minus minus 3, minus times minus give us plus. 5 plus 3 give us 8. 4 minus minus 2, minus times minus will be 4 plus. So 4 plus 2 give us 6. Here, 5 take away 4 will give us 1. Now, how do we find determinants? As a reminder, if you have distribution of elements A, B, C, D, and you have to find the determinants, we cross multiply like this. The first multiplication will be AD. We now take away the second cross multiplication, that is CB. That's what I want to do here. So the determinant here that I have here will now be minus 4 cross multiplying 1. That's, sorry, minus 4 multiplying 1. Then take away 6 times 8. So I have 1 over 2. Minus 4 take away 1 will give minus 4. 6 times 8 will give us 6 times 8. You know that 6 times 7 will give us 42. So 6 times 8 should give us 48. So I have 48 there. So what I have here now will be 1 over 2, 1 over 2 brackets minus 4 minus 14 gives us minus 52. So everything will give us minus 26. But area is never a negative expression. So we take the absolute value of minus 26, which is a 26 squared units. So this is the first method of finding the area of a triangle given the vertices. So I want to start the second method. Now, the same problem I have here, I want to use the second method to find it. How do we do that? We are going to use is called cross multiplication method. That is the product method, vector product method. So area of a triangle is given as half of the absolute value of A cross B. What do I mean by that? Let me rewrite the triangle back again. I have my 1 minus 2, then that is for point A. For point B, I have minus 3, 4. That's for point B. For point C, I have 5 and 5. So what you do, first and foremost, is this. You take this particular point B as a base, as if it is a fixed point in respect to A and C. So that means you are moving in this direction, put this arrow here. Here you are moving in this direction, put this particular arrow. So now, call this particular place, call it vector A, and call this particular place, call it vector B. Now, to find expression for vector A, we find the difference along the x coordinates and then the difference along the y coordinate. These x coordinates are minus 3 and 1. So we find the difference between the x coordinates. So it's going to give us minus 3 minus 1. Call it I. Then we find the difference between uh, the this particular vector we are having here is for vector A. So we find the difference between the y coordinates of the same vector A. So it's going to be 4 minus, that's going to be plus 4 minus this minus 2. Call it J. Now, this place now be minus 3 minus 1, that's minus 4I. Minus times minus, that's plus. So this place become 4 plus 2, that's 6J. So this is vector A for this side. Then for the vector B here, we find the difference between the x coordinates and difference between the y coordinates. So for vector B, the difference between the x coordinate will be 5 take away minus 3. 5 minus 3. We call it for I. Then you say plus. The difference between the y coordinates will be 5 take away 4. That's 5 take away 4. We call it for the j. So vector B now will now be 5 minus minus 3. Minus times minus will give us plus. 5 plus 3 will give us 8. So we have 8I plus 5 minus 4 will give us 1. 1j is same thing as j. So the vector now that we are having, vector A is given as this in terms of the unit vector, and vector B is given as this in terms of the unit vector. So, like I said, the area is half A cross B. So I have it as half, then these two vector. Instead of me writing A, I will write this one. So it's going to be half of the determinant of minus 4i plus 6j being cross multiply with this order for B. By B is 8i plus j. That is 8i plus j. Now, how do we do this cross multiplication? This is how we are going to do it. We can label this vector for the unit vector as I, j, and k. So we say the determinant of it. Now, for the I, we are having minus 4, we are having 8i, then we are having 6j, we are having j there. So for the first vector, we have minus 4 and 6. For the second vector, we are having 8 and j. But there is no vector along the k direction. So we put 0, 0 there. Now, how do we do this three-dimensional vector? We call it 3D vector determinant. We call it 3D determinant because we are having three rows. 1, 2, colon 1, 2, negative sign on top of this thing, plus, minus, and plus. So we cross this unit vector out in this format. When we cross it out, we write the unit vector times, when we cross it out, we are going to have this sub determinants. After crossing it, we are going to have 6, 0. Then this vector is 8, 1, not 8j, because the coefficient here is 1. So when we cross this place off, we are going to have 6, 0, 1, 0. Then when we cross this one up, we are going to have minus j. What will be left inside here will be minus 4, 0, 8, 0. Then for this unit vector, plus k, we are going to have, when we cross this plus k out, it's going to have minus 4, 6, and 8, 1. Now, ordinarily, because I'm having 0, 0 here, by the time I work this unit vector out, it's going to give me 0. This place 2 will give me 0, 2. Then here, how do we solve for when we are having unit vector of this, determinant, 2D determinants? Anytime, please take note of this. When we have 2D determinant, how to evaluate it is this. Just cross multiply this minus this, which is AD, take away CD. So for this particular place that remain here that we want to work out, is going to be K unit vector minus 4, 6, 8, 1. So we cross multiply this as a K times minus 4 times 1 will give us minus 4. Minus 8 times 6 will give us 48. So this one gives us unit vector K times minus 4 minus 14 give us minus 52. So now, like I said, I only work this out. The half wasn't put in my calculation here. So the area now, area of that triangle will not be half of what I have here. Half of minus 52 unit vector K. So 2 in minus 52 give us minus 26K. So the magnitude of this area will now be 26 because area must be positive. So 26 units squared or squared units. Those are the two basic methods of determining the area of a triangle given the coordinates of its vertices. Please, before I go, Do not forget to like, share, subscribe to my YouTube video. Thank you for your time. Have a nice day. Bye.